Today we're looking at empirical formula, but to get our brains in gear a little bit, I'd like you to work out the relative formula mass of the compound and elements mentioned below. So you may need a calculator and you'll definitely need your periodic table with you. Pause the video while you have a go at these. So let's go through the answers. Magnesium is 24, calcium carbonate is 100, calcium oxide is 56, oxygen 16, sulfur dioxide 64, oxygen the molecule is 32. So hopefully you remember from when we were back in school, at the start of our C3 module, we did the magnesium oxide experiment where we started with magnesium ribbon and we heated it at a very high temperature, lifting that little crucible lid very carefully throughout the experiment to make magnesium oxide. And we were looking at it in the context of conservation of mass. And we had increased mass because we were adding oxygen molecules to it, and we made magnesium oxide. You may remember from the worksheet there was a little thing in the corner about working out the empirical formula, and that's what we're going to be looking at today. Now what we need from the experiment is the mass of the elements involved. So I've taken some data from when we did the experiment in class, and we can see from the data collected that we had 0.5 grams of magnesium, and therefore we must have added 0.32 grams of oxygen. So I can take those numbers and I can divide them by their respective atomic mass numbers. And that tells me the number of moles of magnesium I have and the number of moles of oxygen. So I want to look at the ratio between those two things. So to get a whole number ratio, I can divide by the smallest number of that pair. And so in this case, I can divide both numbers by 0.02. And that gives me a number for magnesium of 1.05 and of oxygen of 1, exactly. Now the 1.05 is so close to 1 that we can say that magnesium and oxygen have a 1-to-1 ratio, so the empirical formula is MgO. That was a bit of a flying introduction to empirical formula, but there is a step-by-step process that we can use every time when working out the empirical formula of some compound. So step 1, write down the symbols, the elements in the compound. Step 2, underneath each element, write down the masses, percentages that are given in the question. Step 3, divide each mass by the relative formula mass of the element, give me moles there. Step 4, divide all the answers by the smallest answer to give the ratio. And the final step is state the formula. You'll be surprised at how many people will work out the maths beautifully and get a whole number ratio and then they forget to state the formula. And that's always kind of worth 1 mark at the end. So don't forget that one. If you haven't already, pause the video, write down these steps. They're really, really helpful. So let's go through some examples. So I've been given this question: what is the empirical formula of a compound that contains 27.3% carbon and 72.7% oxygen by mass? So if you're feeling confident, pause the video and have a go at that using those steps I've just mentioned. So step 1, write down the symbols. There we go, got carbon and oxygen. Step 2, write down the mass percentage we're given. So we're given these percentages and we're just going to treat it like we have 100 grams in total of this stuff. So we've got 27.3 grams of carbon, 72.7 grams of oxygen. Just plug the numbers in. Step 3, divide each of these numbers by their relative formula mass. So for carbon we're dividing by 12 and for oxygen we're divided by 16. And we get those numbers in red. Step 4, we're going to divide them by the smallest of our previous answers. So we're going to do 2.3 divided by 3 to give us 1, and 4.5 divided by 2.3 gives us 2. And so our formula is CO2. Don't forget that. Right, this one's a past exam question. So compound X has the following percentage composition by mass: 10.8% magnesium, 31.8% chlorine, and 57.4 oxygen. Calculate the empirical formula of compound X. So I put the steps up there for you to see. Have a go at this one, pause the video, and when you're ready, check the answers. So, step 1, write down the symbols. Step 2, we're writing down our percentages. Step 3, we're dividing each mass by relative formula mass, that you can see there. Divide all by the smallest answer, so that's 0.45 in this case. So that gives us magnesium 1, chlorine 1.99, so we can round that up to 2, and oxygen is 7.97, so we can round that up to 8. So we've got our whole number ratio there. So our formula is MgCl2O8. Right, another question for you. You're going to do lots of practice so you feel confident. A compound is called phosgenite. Analysis shows that it contains 76% lead, 13 chlorine, 2.2% carbon, and 8.8% oxygen. Calculate the empirical formula of this compound. So again, pause the video, then have a go. So let's go through the answer. Step 1, write down the symbols. Step 2, write down the percentages. Step 3, divide them by the relative formula mass. Then we're going to divide by the smallest, in this case that's 0.183, and that gives us the ratio and the formula then, Pb2Cl2CO3. Again, another example, I'm spoiling you today. A sample of a solvent used in one perfume contained 0.6 grams of carbon, 0.15 grams of hydrogen, and 0.4 grams of oxygen. Calculate the empirical formula of the solvent. So going through the answer, step 1, state those symbols. Step 2, write down the masses that we are given. Step 3, we're going to divide by the relative formula mass of each element. We're going to divide by the smallest answer to give a ratio. So we're going to divide by 0.025 in this example. So that gives us the numbers carbon 2, hydrogen 6, and oxygen 1. So I'm hoping you're feeling a bit more confident now. So here's a slightly trickier one, not much more. Make note of the tip in the corner. So calculate the simplest empirical formula of a substance that's 70% iron and 30% oxygen. Pause the video, have a go. So, step 1, write down the symbols. Step 2, write down the percentages. Step 3, divide by the relative formula mass. Divide our answers by the smallest one to get the ratio. So we've got a ratio here, this is where it gets interesting, of 1 to 1.5. We want in empirical form to get the smallest whole number. So how can we make that a whole number? We're going to want to double. And we've got to be able to double both sides. So that gives us a ratio of 2 to 3. So our formula is Fe2O3.